This short video is looking at how to calculate the ratio of abundances in a relative atomic mass calculation. This question comes from January 2011 and it is question 2C. The information needed for this calculation is given here, which tells us that we've got two isotopes of indium. One has a mass to charge ratio of 113, the other has a mass to charge ratio of 115. The relative atomic mass of the sample is 114.5. Part 2 says use this data to calculate the ratio of the relative atomic abundances. How are we going to do that? What we have to remember is that the relative atomic mass is worked out by looking at the mass multiplied by the abundance of one isotope, add to that the mass multiplied by the abundance of another isotope, and so on and so forth for all these particular isotopes that you have present. In our case, we only have two. Now we know, because this is a relative atomic mass calculation and we've been told it's relative abundances, then it's actually out of 100, i.e. that the sum of the abundances must equal 100. So that is why we're dividing both of these component parts by 100. Okay, so let's suppose that the abundance for one of the isotopes is X. Then we know that because both isotopes must add up to a total sum of 100, then the abundance of the second isotope must be 100 minus the value of X. And that is the key to understand this question. So, going back to the particular question, our information in the question has been given to us that we have got a mass of 113 here, and we're going to multiply that by the abundance and we'll call that X. As I've just said, we now know that the abundance of the other isotope 115, must be 100 minus X. So therefore, the sum for the second isotope is 115 multiplied by 100 minus X. All of this is going to be divided by 100, and this value equals 114.5. Now it's just a matter of trying to simplify the equation, go through the workings out and get X on one side. That I've done here. So, so the first thing to do, the first thing I've done is I have simplified the brackets shown here, and so I've got 113x plus 11,500 minus 115x, all divided by 100 equals 114.5. I'm going to simplify it by multiplying both sides by 100, so that gets rid of my fraction, and now we're left with 113x plus 11,500 minus 115x equals 11,450. Simplify that down. Minus 2x equals 11,500. Sorry, say that again. Minus 2x plus 11,500 equals 11,450. Add 2x to both sides, and then subtract 11,450 from both sides. So x is on its own. So we get 2x equals 50. X equals 25. So therefore, if X equals 25, which is the abundance of isotope 113, then the remainder, which is 75, is the abundance of isotope 115. Therefore, the ratio is 1 to 3. Okay. Any further questions, please give me a one-man June.